Have you ever wondered what's really going on under the hood of an AI system? Well, I can tell you, it is definitely not magic. It's actually a massive collaborative effort, and it's powered by a very specific set of tools. So in this explainer, we're going to pop the hood, open up that toolbox, and see exactly what it takes to get from a simple idea to a fully functioning AI. You know, the first thing you really have to get your head around, and this is so important, is that AI is a team sport, through and through. The source material we're looking at today just puts it perfectly. Artificial intelligence is not built by a single person. It's developed by cross-functional AI teams. Now, what does that mean? Well, it means you've got data scientists, machine learning engineers, software developers, project managers. All of them have to work together. And for any of that to happen, they all need a shared workshop to build in. So that brings us to the big question, right? What does an AI team's toolkit actually look like? We're about to walk through the entire journey from the very first line of code all the way to the final product to see the specific tools that make it all possible. Okay, so our first stop is the foundation. Before anyone even thinks about a complex algorithm, the team has to set up its workshop and agree on the blueprint. This is all about collaboration and just the core nuts and bolts of development. So check this out. The first big insight here is that the most fundamental tools in an AI toolkit have absolutely nothing to do with fancy models or algorithms. They're about people. We're talking project management tools like Jira or Trello, nonstop communication on Slack or Teams, shared brains like Confluence or Notion, and, this one's a biggie, version control systems like Git to manage the code itself. Okay, so once the team is organized, it is time to write some code. And yeah, you'll see languages like R or Java on the slide, but let's be real, Python is the undisputed king of the AI world. Why? Well, it's pretty simple to use and has this massive ecosystem of libraries that are ready to go. Now, developers write their serious production code in IDEs like VS Code, but the real creative spark, that often starts somewhere else entirely, in these cool interactive environments called Jupyter Notebooks. And our source material really nails this description. A Jupyter Notebook is kind of like a scientist's lab journal. It's where all the initial, messy, creative, and sometimes totally groundbreaking experiments happen before a model gets all cleaned up and ready for the real world. All right, let's move on to the next stage and see how this all connects. An AI model is an engine, right? But every engine needs fuel. And in the world of AI, that fuel is data. High-quality data is absolutely everything, and getting it ready is a huge job. This whole thing is called the data pipeline. First, you have to collect it all, pulling raw data from APIs or scraping it from the web. Then you got to store it somewhere, either in a nice structured SQL database or a more flexible NoSQL one. But that last step, processing, man, that's where the heavy lifting happens. This is where Python libraries like Pandas and NumPy become the team's best friends, just cleaning, transforming, and shaping all that raw data into the perfect fuel for the AI model. Okay, so we've got our team and we've got our fuel. Now it's time to actually build the engine. This is the real heart of AI development. It's where data scientists and ML engineers use these incredibly powerful frameworks to build and train their models. Now, it's important to know that not all building blocks are the same. For standard tasks, like classifying something, a library like scikit-learn is perfect. Think of it like a set of pre-made parts. But if you want to build something really complex from scratch, like a giant neural network that can recognize images, you need a full-blown framework. And that's where the heavyweights, like Google's TensorFlow and the research community's darling, PyTorch, come into play. But here's the catch, and it's a big one. Building a model isn't a one-and-done kind of thing. Nope. An AI team will run hundreds of experiments, tweaking tiny little parameters each time to see what works best. Can you imagine trying to keep track of all those results in a spreadsheet? It would be total chaos, an absolute nightmare. And that is exactly why a whole category of tools exists just for tracking these experiments. You've got platforms like MLflow or Weights and Biases that automatically log every single detail of every run. And then there are tools like DVC, which stands for Data Version Control. It basically does for gigantic datasets what Git does for code, letting teams version everything so they can always go back and reproduce their results perfectly. So the team has run hundreds of experiments, and they finally did it. They found a model that performs really well. That's awesome. But here's the thing. A model just sitting in a lab is totally useless. The next critical step is getting it out into the real world, where it can actually provide some value. And that is the world of deployment. This whole process is so important, it's got its own name, MLOps. The easiest way to wrap your head around it is to think of it like DevOps, but for machine learning. It's all the practices and tools you need to deploy models reliably and, make sure they don't break down once they're live. Now, two of the main pillars of MLOps are containerization and the cloud. First, you have tools like Docker that package up the model and all its dependencies into this little self-contained box called a container. It's key for consistency. Then, a platform like Kubernetes acts as the orchestra conductor, managing maybe thousands of these containers all at once. And where does all this run? Well, on cloud platforms like AWS, Google Cloud, or Azure, which provide all the raw, scalable computing power needed to serve that model to millions of users. All right, we're at our final stage, but the job is far from over. A deployed AI model isn't something you just set and forget. It's a living system that needs constant care and attention to make sure it stays accurate, fair, and secure over time. Let's call this the Guardian Protocol. First, you've got monitoring tools, like Evidently AI, that are constantly watching for what's called model drift. That's when a model's performance starts to slip as the real-world data changes. Then you've got standard software testing with tools like PyTest to make sure the code itself is solid. And finally, and this might be the most critical part, teams use tools and techniques like SHAP or Lime to make sure the model's decisions are transparent. They give you a peek inside the black box to see why the AI made a certain choice. So, after all that, what's the big picture here? The key takeaway is that modern AI is not built with a single magic tool. It relies on a complete, interconnected ecosystem of tools where every single one plays a vital role at a different stage of the journey. And in the end, it really just boils down to this simple but incredibly powerful formula from our source material. A successful AI system is the product of having both the right tools for the job and the right cross-functional team that knows how to use them together. This leaves us with a pretty fascinating final question, doesn't it? We've just walked through the toolkit of today, but AI is evolving at a crazy pace. As the models get even more powerful and complex, what will the next generation of these tools need to do, and what kind of new capabilities will they unlock for all of us?